So today's agenda for this session, we'll learn how to build a video conferencing app like Zoom or Google Meet and how the video conferencing apps work. So this session will be hosted by Aniket. He's a co-founder of 100ms. A little bit about 100ms. So who we are, 100ms is a live interaction audio video SDK. Let's say if you want to add the capabilities of audio video conferencing in your existing application, or you want to build something like this, you can use 100ms audio or video APIs to build the product that you want. Let's say if you want to build some app similar to Clubhouse, you can use the audio API of 100ms. But in today's session, we'll be focusing on how to build video conferencing app similar to Zoom. 100ms already have some templates, as you can see. Let's say if you want to build for video conferencing, online classroom, virtual events, or audio rooms, or even you can create your own custom audio video application as per your need. We are fairly young company. We are just 8 months old, but yes, we are loved by the developers. And going through the agenda of the session, today's session, today we'll learn, we'll go through intro to the key concept of video conferencing app, and then we'll learn how to build your first video conferencing app with using 100ms SDK. Then at the end, we have a Q&A session and giveaway announcement, which we'll be doing on Discord, our Discord server. So by the end of this workshop, you'll be able to understand the basic of video conferencing. After attending this workshop, you'll be able to understand the basics of video conferencing, how to create video conferencing application, how Zoom and applications like Meet work. You will be able to understand those all. And another thing, you'll be able to deploy your first video conferencing app using 100ms SDK live after. If you just follow us during the session, you'll be able to deploy your own video conferencing application after attending the session. This is going to be super exciting and interesting, so stay tuned. We are also running a giveaway for this session. Participating in a giveaway is super easy. You just need to use the hashtag built with 100ms and tag us on Twitter and share your learnings. If you want to participate in the giveaway, share your learnings from this workshop using hashtag 100, build with 100ms and tagging us at the rate 100ms.live. And we'll announce 3 winners for the Twitter contest and our Discord server after the workshop. Yes, so here's the link to our 100ms community. So before starting this session, I'll workshop actually, I'll request you all to join our server on Discord. So you can go through this link bit.ly/100ms Discord, and you can join our Discord channel there. Feel free to join Discord channel to know more about future events, community programs, resources, and opportunities with 100ms. And here's something about our facilitator for the workshop. Today's workshop, will be hosted by Aniket. He is a co-founder of 100ms, and he's previously was the ex-director of Disney Hotstar, and he's also a jobbing actor. And believe me, he's like super amazing person. So this workshop is going to be super interesting, and and feel free to let us know about in the chat section, like from what's your name, from where you are joining in, and what is your domain. We would love to know more about you. And till then, over to you, Aniket. You can continue from here.
All right, thanks, Divyansh. I've done a bunch of things, but it still annoys me to have a jobbing actor as my last point of introduction. Super excited to be able to explain how easy it has become to add your own personal video conferencing application into your whatever application you have, whether it's on web browsers, Android devices, iOS devices, something that we enable, something that we are super excited about enabling. Let me just quickly share my screen. Can you guys see my screen? Yeah. All right. So the agenda is to build a video conferencing from scratch. So the entire workshop will be super hands-on. We'll be diving into the code very, very quickly. And what we are hoping to achieve is to be able to get a full-fledged video conferencing up and running. Man, this result looks a little lonely because it's just me, but hopefully we'll also have a bunch of you folks joining the end result. So the idea is to take something like this, just a basic empty React code sandbox, and get it up to this level. So this is me joining the end result app from one tab. I'll just open another tab. This is what we should be achieving over the next 30 minutes. Hopefully you guys will all also realize how easy this is to build. And hopefully we'll also have a bunch more folks here. Right. All right. Before we start, I'll just spend some time taking you through the key concepts of a video conferencing setup. The first basic concept is just a room. A room is a collection of people who are together, whether it's an audio room, a clubhouse session is also a room, a Zoom meeting is also a room. It represents a session of real-time audio, video, and the basic building block of everything that follows in 100ms. The next key concept is a track. A track can either be a video track or an audio track. It's fairly self-explanatory. When I'm talking to you, what you see being rendered is my video track on Zoom. And when I'm talking to you, you guys hear my audio track being rendered. Right? We usually call participants in the video conferencing world peer. It's just German or fancy for a participant. So all of you are currently peers. You are not publishing any audio or video tracks because you're in view-only mode. But you're still peers who are all subscribed to my track, and we are all in a single room. (100ms) integrations, or most video conferencing SDK integrations, are usually largely client-side. I'll take you through the steps and then we'll go through them one by one. The first two steps are on the server side. These are very thin steps. The first is to set up roles, create an app, and create a room. We'll explain what that means, which is effectively creating the framework of what kind of a room that you want. Right? The next is generating a joining token. If you guys are familiar with tokens, 100ms internally uses a JWT-based token authorization method. I'll link you to relevant sections of our documentation for you to read more. But essentially, every time a person joins, you have to send a token that verifies that this is a peer who we vouch for joining a room, who we vouch for, so then we can authorize that person to join. Most of the heavy lifting is done on the client side through either integrating our JS SDKs, React SDK, our Android SDK, our iOS SDK. For this workshop, we'll be using React SDK as that's the simplest and quickest way to get started. I'll also be giving you some asides if you're not comfortable with React about what the JS equivalent is, but everything that we talk about today around React, you'll find it equivalently in JS, you'll find it equivalently in Android. So coming to the client-side SDK integration, on a client side, you will first join a room. You will first then send local video audio tracks to all peers in the room. This is another nomenclature, local and remote. So for example, for me, my track is my local track and everybody else's track. So which is, for example, Divyansh's video and audio track, Tushar's video and audio track are remote tracks for me. So the first step is to send your own local video track to everybody else in the room so that they can start seeing you. And then the next piece is rendering everybody else, accepting their audio and video tracks and rendering them. If you're doing just audio rooms, just remove video, everything else still works. Guys, keep asking questions. Tushar is here. He'll prompt me to answer questions somewhere in the middle. I hope to intend to sort of transform this into a more interactive workshop by the end of this, but it only works if you guys keep on asking questions, and happy to step in and answer. All right, so just summarizing, set up your app, set up your roles, explain what kind of an app you're building, whether it's a video conference or an audio room, then generate a joining token, very quick step to just secure entry into the room. And then client-side integration about joining a room, sending your video, rendering everybody else's videos. Let's go through them step by step. The first step, setting up app, the roles, and creating a room is done on the dashboard. You can also use our server-side APIs. But for the sake of this workshop, we'll go through our dashboard. So these are, if you just log into dashboard.100ms.live and sign up, this is the first screen that you will see. The idea is to set up something called roles, and roles are the cornerstone of 100ms's SDKs. If you guys are familiar with other video conferencing SDKs, this is where we separate ourselves. For those who are not familiar, think of a role as a set of strategies that tell us, okay, what is the video quality or audio quality that we need to be sending for each user, and what can that user do and what can't that user do. So for example, in our case, let's just build a simple video conferencing app. Let's call the first role as a host. The host should be able to publish audio, which is okay. I should be able to say something and everybody else should be able to hear me. Publish video, should be able to screen share. Let's keep the video quality a little high at 720p. The screen share that I can share is at 1080p as the host. All right. I'll come to subscribe strategies in a bit. Let's take the new role, guest. Let's make the guest, let's make it a normal video conferencing where the guest can also publish an audio, publish video. Let's remove screen share rights for the guest. This should make the guest's video quality set. Now let's talk about who should the guest be able to see? Who should the host be able to see? So the guest should be able to see the host and the guest, which is essentially everybody in the room. Similarly, the host should be able to see the host and the guest, which is essentially everybody in the room. For most video conferencing use cases, you should be able to see all the roles. So you're effectively seeing everybody. But for example, in this particular use case, right? So we are doing a Zoom webinar where you're all viewers. We would have added a new role called viewers, and we would have said that the host and guest do not subscribe to viewers, which would have ensured that, okay, and the viewers also wouldn't have published their audio and video. That would have ensured this is an equal room. So all the panelists can see themselves. So basically all the hosts and guests can see themselves, but a few people can only be, can't be seen by anybody else. All of this is decided and described on our dashboard. You can also have, you use APIs to define the same thing, but this is the key cornerstone of a 100ms SDK. After you've defined roles, all that you need to do is basically call our join method in our SDK. After that, if you are a host, then you'll automatically get subscribed to all the guest videos, all the host videos. Your video will automatically get published with the right video quality. And this is all completely customizable by you. And you'll realize the power of this hopefully by the end of this session. Right? So now that we've done this, let's just set up our app. Great. Our room is created with a host, a guest. Guest does not have screen share permission. Host has video and audio permission. All right. This does two things. It creates a custom app, which is we can create multiple such apps. You can create an audio room app. You can create a video conferencing app, etc., etc. We just created a simple video conferencing app. And now the second thing that it does, it allows us to create rooms for this app. You can create multiple rooms. For the sake of this workshop, we'll just create one room and just keep on using it. Right? So let's just call our room, let's say, workshop demo. We also have a recording feature. Let's not record this, but it's easy to record these rooms as well. All right. I will just store this room ID. I'll copy this and we'll use this when we are joining. All right. So now we've set up our app. We've created our roles and we've created our room. Let's jump to the next step. Before we jump to the next step, it will be helpful, which is now effectively now we'll be getting into our JS or React SDK architecture. I just wanted to pause for a bit and take you through how our React SDK is structured. If you guys are familiar with Redux or any other data stores, if you guys are coming from the Angular world, there's NGRX or any data stores, Zusta and Jotai, we follow a similar paradigm wherein you have two separate modules within the SDK. One is the data store, which is called HMS store. And there is a set of methods which is exposed through our HMS action module. A store is basically exactly what it says. It's a data store that captures the entire state of the room. So whether the room is connected or not, give me all the peers with their names, their tracks, what is their mute status, and actions are anything that will affect the state of the room. Joining a room is an action, muting myself is an action, starting screen share is an action. So you'll either be getting variables or values that you want to render from the store, or you'll be affecting the room by calling one of the actions by either joining or muting. Right? All of the steps that I've just taken you through are also up on our documentation website. So we are doing effectively just an expanded video version walkthrough of our documentation website. So we've taken you through the basic concepts, room, track, peer. We've taken you through how to build your own room and set up roles, etc. We've explained what actions in store are. Now let's actually jump into the code. All right. So this is a very bare bones boilerplate that I've built. It's based on Create React App, Code Sandbox is default app. The only modifications that I've made is including Tailwind. Any Tailwind fans in the house? Tailwind is the simplest way to style a very quick application. What I've also done is the first getting started step that we've just talked about here, which is include the HMS video React and the HMS video NPM package. These are the two things that I've added: 100ms live HMS video and 100ms live HMS React. Now let's start actually adding HMS video into the application. All right. All of our essentially all our variables, all our actions and stores are effectively provided by context providers. For those who are familiar with React, this is just a context provider that will provide the actions and the store hooks. For those who are not familiar with React, don't worry about this. You just need to import HMS room provider and HMS theme provider from the video React SDK, right? And then just wrap your entire app around with these theme room providers. Just a quick aside on, just hang on, sorry. All right, where have I messed up? HMS room provider should be the first one. HMS theme provider. And is there a space somewhere?
Can you remove the comma restriction?
Hang on, let me just take this from this thing. All right. The perils of live coding. So just a very quick aside. So this is just simply replacing, just wrapping the entire app with room provider and theme provider. Just a very quick aside. Room provider is the only context provider that we'll be worried about. Theme provider is something that will come in the future. It's not a part of this workshop. We're also building our own UI component library, which this theme provider will use. But for this purpose of this workshop, just to be very clear, 100ms SDKs don't assume anything on the UI. The UI is completely on the client side so that they can customize it themselves. The room provider only provides you the raw variables to be able to render that UI. So whether it's peers or tracks, and which is what we'll be concerned about. All right. Now that we've added the core providers, let's now start actually building some of our applications. All right. Just going through the documentation again, the first step is to call the join method. To be able to call the join method, we need some kind of an input field which will take in the name of the person and which will also just show a join button. So let's just create a component here. Let's just call it the preview component, which is standard, something that we do in video conferencing applications. Just import React and let's make a component called preview screen. That's it. Now let's just keep it a fairly simple. This is a fairly simple UI for a simple preview form, which is a form with an input and a button. Let's just say set these. I'll take a single variable for username. Let's initialize this. And let's just include this here in our app. Instead of doing this, let's just start returning review. Let's do an import review from. We should be calling it. All right, we're good. All right, we've just drawn this up. Let's now actually link this method to something. Let's create an onSubmit method button. What we want to do is on the click of this button, we want to be able to call our join method. To be able to call our join method, let's accept a callback for submit. And let's create a dummy submit button for now. All right, let's just create a dummy handle submit. This should drop our basic preview component. Now what we need to do is we take the username here, and as soon as the username is entered, we call the join method. Let's look at the join method's code. The join method takes the username, which is the name that you want to display, and an auth token. An auth token is basically a hashed secret way of signifying, okay, this is the user, this is the customer, and this is the room that this person is trying to join. It combines all of this information into a single entity for our servers to understand this. So how do we generate a token? This is explained in our token generation documentation here, but essentially you need to set up your own server, which will take all of these things and do a simple hashing of all of the inputs and generate a simple a JWT token. For simplicity, what we've done is we have created a dummy token generation endpoint for all our clients. So instead of writing the server, you can just copy this directly. So let me just copy this directly and add it to the code. Endpoint and let's now, when you submit is called, let's now call the token endpoint with the input values, which is the username, etc., and get the token in response. So let's just create a very quick get token method, which does nothing but just sends a post request to this very endpoint with the user ID that is passed to it. In this case, let's assume the username is the user ID. With the role that the person is joining with, we define two roles, host and guest. For the sake of simplicity, let's just hard code it to host for now, and the room ID that the person is joining. We created a room ID. I had copied it initially. Let me just copy and paste that. All right. So we have a token endpoint, a token method. Now we just need to link it to our handle submit method. So what we'll do is we'll just add, we'll get the token here, and this is where most important things happen. Let me just convert this into a function here. Give me. Not the best to do this. It's equal to async, and this is async. And now we call our, so now we generated the token. Now we have to call the join method using this token. And this is where you start interacting with the HMS SDK. For this, you'll need to include the HMS actions module. So let's just quickly import that. All right, let's just define HMS actions here. All right, and we call HMS actions.join with the token that we've received, and we send the username as the username that we've received from our submit method. Let's just quickly see if this works. Perfect. All of these console logs effectively mean that you are now connected. Right? The token has been generated, you joined, and you connected. Now, next, what we have to do is, now that we're into the room, now let's actually start querying the room for all the details and rendering all the relevant information. The first thing is, as soon as you joined, you have to switch the view as soon as your connection is done. So now let's figure out when the connection is done. For that, we will create a variable called isConnected, which will use HMS store. And here we will use our first selector. I'll explain selectors in a bit. Connected, and what we'll do is we'll just do let's just quickly switch this. So if we are connected, then show something like, hey, joined. And if you're not, show the preview component. Right. Is connected to room is a selector that we have to. All right. Let's just quickly see if this works. Perfect, join. So now I'll explain what I did. And this is one of the improvements that we've done over existing SDKs is effectively, as we said, all of the state of the room is captured in the store. And this could be, hey, whether the user is connected or not, whether how many peers there are, whether the person's local audio is muted or not, whether local video is muted or not. All of these are now stored in the store, and you can query the store using something called selectors. They effectively take that entire state tree and traverse through it and just give you exactly the value that you need. So for example, if you want to know what all the details of the local peer, you just use the selector select local peer with our use HMS store hook. If you want to know who is connected, you just say, okay, give me the select is connected to room selector value using use HMS store. What this does is if you're coming from if you've used other SDKs before this, there's typically a lot of boilerplate coding here that other SDKs have, where you have to listen to certain messages and update your own local state. And because these apps are so reactive, real-time video conferencing apps, there's someone joining, there is someone leaving, you're muting yourself, and all of these happen across multiple callbacks. Maintaining state typically increases surface area for error. What we have really done is, once you have called our join method, we will create this deep state tree and we will maintain it. After that, you are just subscribed to each of these tiny variables, which is whether you're connected or who's the local peer. You don't have to listen to messages and wait for it to get updated. This variable is constantly updated. You can just put in with React or Angular or whichever framework that you're using, just link your UI changes to these variables. All right. So now we've created, what we've successfully done is taken an username, and successfully joined to a room and switched the UI. Now let's actually show in this UI the real meat of the problem, which is the room UI. Let's just create a room UI. Right. We'll create a very simple room for now. And simple gray background should do. Let's just default export this, and instead of joined, let's actually show the room. And let's import room here. All right. Great, we are in the room. Now let's actually start rendering this room with information about the local peer or the person who's joined. For that, what we'll do is we'll just import another selector here. Same way we connected the isConnected selector. We'll just import a select local peer selector, and we will just store that in a variable. And here, let's just actually start showing. Let's say if local peer exists, then show me the local peer's name. That's all. Perfect. Now we are seeing the local peer's name here, right? So this is the next big hurdle selected, which is, okay, we've joined, and now we've also gotten details of the peer, which is the name. Now let's actually, instead of this name being rendered, let's actually render their video, which is the next piece. And this is the basic unit of all video conferencing operations, which is the video tile component. Let's go through this in a little bit of detail. Const video tile equal to, let's take 2. You give me the peer and tell me whether this is a local video or not. So the way video conferencing works is people are used to seeing their own videos mirrored. So while rendering local videos, you mirror them, but everybody else's videos, you don't mirror them. So isLocal is a useful prop to get for video type. Tushar, feel free to just pause me and ask me some questions at any point of time if you think there's a legit question that's relevant to this section. All right, let's actually build a quick video component. All right, let's go look at the ref later. But this is a very simple video component. What I've done is just taken a HTML video element. We made it to, we've configured it to say autoplay to true, muted true. One of the things that we do with 100ms SDKs is the audio is automatically played. So anybody's audio, let's say someone is, there's a remote peer who's publishing their audio. That audio isn't linked to the video track. That's automatically played by our SDK. While this might sound complicated, this simplifies a lot of autoplay issues that come. So when you play the video, you just play the video. Audio will automatically play by the SDK. So which is why when you play any video, you'll always mute it. So muted true, autoplay true, just some basic styling. And if it's local, add a mirror class, which we'll add later, what to do with the mirror class. And I've also added a tiny label for the name here that will come up in the center. All right, so now that we've done this, let's actually attach the video track, which we get from the peer object, and attach it to this video element. For that, there is a method called attach video, which will take in, okay, this is the video ref of the element that you've drawn on your UI. This is the video track that you get from the peer, from the store, and attach video basically links both of them. So this is the piece of code that we have to link here. Let's just put that down. First, let's get our actions in. I'll have to import them. So this actions is done. And then what you want to do is whenever video React changes, for those who are not familiar with React, effectively what we're doing is trying to just, we're attaching a listener of sorts to video track. So whenever the store says, hey, the video track has changed, we'll tell you how to get the video track, then attach video effectively is what we're doing. So let's just get the video track now. Again, as always, we'll use a store for this. Let's get the store data. Store, the selector that we use this time is a selector called select camera stream by peer ID. So given a peer, give me their camera stream. A peer could be publishing their screen share stream, the camera stream, and you might want to publish them in different places. If you just want the camera stream, you can use the select camera stream by peer ID. And we obviously need the store as well. All right. What we are doing, this piece of code is whenever video track changes, check if our video element has been loaded and check if there is a video track. If yes, and video track is enabled. Enabled state signifies whether the video is muted or not muted. If the remote peer or the local peer, whichever video is being rendered, have they muted their video or not? If they have not muted their video and the video is enabled, then just attach the video and start rendering it. If they've disabled their video, just detach it. This internally tells us to unsubscribe to that particular video. That's it. This is the toughest piece. I'll just summarize what we did. Created a simple video element, attach it to the video track. To get the video track, we took the peer and use a selector called select camera stream by peer ID. All right. Now let's actually integrate it into the room. So instead of this local peer.name, let's actually render the video tile. And we pass the peer as local peer and is local since this is the local. Let's actually import video tile also here. All right, I think this should be good, but let's just confirm once. Perfect. My video is ready. We rendered the video. My name is here. That's all. This was this simple. The next step is super simple, which is just copy the same step for all other peers. So instead of this, select peers. Select. There's one nuance. When you select all peers, we give you the local peer as well. So we'll have to filter out the local peer since we've already displayed it. So peers and peers dot. Give a minute. Let me just pick this up. Make sure mistakes. Yeah, sorry. Peers and peers dot filter out all the peers who are not local, and then map them to the video tile components. This should do it. Let's just quickly see if this makes it work. I'll just join from another tab separately. Let's just take this here. And I'll join as Aniket 2 here. But essentially there are 2 videos, and since both of the audios are playing, you hear the echo. All right, so we've now rendered remote videos also. We've rendered local videos also. It's taken us 30 minutes to get here. Now let's do the final piece, which is the only piece of control that matter in a video conferencing, the ability to mute or unmute yourself. So let's just add a control bar at the bottom. Let's just do a very quick control bar component. The control bar is effectively 2 buttons. We created the component, but it's a very simple 2 buttons which are styled. One button says either mute or unmute, depending on whether your audio is on or not. Another says whether it's hide video or unhide video. And they're all linked to a method called toggle audio and toggle video, which we will define right now. So toggle audio is, as always, muting is an action. So we'll import HMS actions. Right. We will also need to define is now when we toggle audio, we are effectively trying to say, okay, if the person's already muted, then unmute them. Let's now get the variable of this person is muted or not from the store. We have a selector for this. Select. It's already gotten selected, but let me just add it here and store as well. Done. Muting is done. Let's just do the same thing for video. Let's just see, okay, everything matches up. Now let's just link this to, let's put the div somewhere here, I think.
There is an extra semicolon in the input.
Sorry, where? This one?
Yeah, no, it's resolved now.
Sorry.
Can you open the control bar component once?
Oh yeah, I haven't imported it. All right, let's just see if this comes up. Hang on, what dependency is not there? Let's just see if there is some error here. Import, did not find. Okay, right. Oh yeah, got it. Let's just see if this works out. All right, I am joined here. Let me mute myself. Oh, I've just somehow attached the wrong variables. Is local video, audio, local audio, video, audio, toggle video, video. Which piece is not?
This selector for local video.
Sorry. Select is local video, which I'll have to import. All right. Mute, unmute, hide. Yeah, let's just test it out. If I mute myself and join from another tab, then the echo should come. All right, if I mute myself, the echo doesn't come. Let me hide my video here, and I should be able to see that the remote video is hidden here. Yeah, awesome. So that's all. I'll pause here. I'll share the link. So if you guys want to join into this conferencing room, you can join. But this is the final result. A very simple video conferencing application done in 30 minutes, a little over 30 minutes, let's call it 45 minutes, with just the bare minimum lines of code, fully functional. You can mute yourself, unmute yourself, multiple people can join, they'll all get arranged nicely. You can see their labels. We can add a little bit of fancy work on top of this, where we can show some mute indicators. Again, just query the store, show it. We can add a leave button to leave. We can do a bunch of other things, show audio levels. If you're just doing audio rooms, just remove the video tiles and just play audio. I'll pause here and I'll start taking questions.